Hello and welcome everyone. So I'll be explaining the recent Codeforces round like Div 3 734 like problem B2 like basically you could call it problem C. Wonderful coloring too. Okay, in this problem basically you're going to be given a bunch of numbers containing an as an array. Like inside that array there will be a bunch of numbers and each number will consist of some values. Now what you're asked to do, or what you're like given a task to do, is to like you have to paint these array indexes with k colors in such a way that each element of the sequence is either painted in one of k colors or is not painted. So you have the independence whether you color one index or not. And the number 2 condition is that no such two elements of the same colors values should be same. So they should be different. For same group of colors, as you can see here, 3 and 1 are colored as red, but their values are different. Similarly, 3, 1, and 10, they're different, but they're in the same group of colors. That's exactly what we have to do. We cannot maintain same color, like same number of values, which also contains in the same number of color groups. I hope you get that. Now, what is the third condition here? They're saying that also the third condition is that you have to color when you color the array, you have to color like k colors, and the condition is that each and every color groups of members should be equal. As you can see in this array, if I demonstrate here, in this array, like 3, 1, and 10, so we've got one group of member of 3 containing red colors, or like red color painted, and the other color is blue containing exactly 3 members. Similarly for green, exactly 3 members. Of course they are containing different values for each and every group, like 1, 10, 2 for green values, and for blue values 1, 10, 3, 3, 1, 10 similarly. So and yeah, so basically you have to meet these 3 conditions such that finally what they're asking you to is you have to minimize the number of unpainted or like non-painted colors, or maximizing the number of all the colorings of the sequence by meeting the first 3 conditions. Can you do that? If you do that, then you have to output the resultant array by saying that yes, I have colored with this color with this color, or like any color number, like from 1 till k, color from 1 till k. So the final array for each and every values of the final array will contain values from 1 till k, whether you color it or not. Think about it. About this example here, they have already given this example. The first example is actually described here, so let's just demonstrate that here. Think about it here, like the resulting array for this sequence will look something like that. One could look something like that. There could be like, you could organize the outcome or like the output in your own way too, but the bottom line is that how it's actually working. What is the final array returning? It's actually returning which color you are painting with. So k is 3, so you have color 1, color 2, and color 3. So you're sure that you have to build 3 groups of colors containing some number of members. Here it is each and every group containing, also each and every group should contain same number of members as the condition is told. So as a result, it gives that we can see that each and every group containing 3 members. Yes, it is possible to make. How is it possible? If I like color 3 and 1 with red, and we have got 310 values. So okay, I'll demonstrate how actually they have organized this final area, or how are we gonna actually color that. Now we need to discuss something here before we jump into organizing the array, which is what we actually have to do. What is the main condition? Main condition is that each and every group should have same number of members, and no two members of the same colors value should be same. They should be different. So it does make sense that you will count. So the initial arrays, not every value is going to be like distinct. That's obvious. Some values could be occurring more than once. So what I thought about it like that is, okay, I will count the number of occurrences for each and every values from 1 till n, and for those values I will say how should we distribute these values such that we could maximize the number of colorings. Let's assume that our k is 3. So we have color group of 1, 2, and 3, right? We have color group of 1, 2, and 3. Now, what did I told? I told that I'm gonna count the number of occurrences of the initial array values. So if I take account for this array, I will say that 1 is occurring 4 times, 10 is occurring 3 times, 2 is occurring only 1 times, and 3 is occurring 2 times. Okay, yeah. So how is this gonna help us? Like, we're counting the number of occurrences of each values of the initial array. How is this gonna help us? First of all, we will say that, okay, if the number of occurrences of any number itself is more than, or like greater than or equal to the number of color group, here the color group is like 3. Let's take for this array, we have 1 count of 4. Now think about it. 4 is greater than 3, right? 4 is greater than 3. Now, can we say that, okay, what I will do is, I have 4 ones, right? What if I distribute them like that? Is it gonna meet the condition? Yes, it will, because they are different color groups. They could have same or different values. But if the color groups are same, they cannot have same number of values. That's exactly why we are distributing the occurrences of each and every number in such a way, like distributing among the colors one by one. Now think about it. We've got 4 ones. Now we're distributing 3 of them just like that. One goes from in group 1, the other one goes in group 2, the other one goes in group 3. But we are one value we left. We're like, we do have extra 1 value. Now what are we gonna do with this value? Now I'm guaranteed, or like I'm sure that if I use this one in any of my groups, my condition will not be fulfilled, because I know that I cannot have same values in my same color groups. So it does make sense. If I do that, it's not gonna fulfill the condition. I hope you get that. It's in the third condition, I hope. I guess, yeah, it was in the third condition that I cannot have the same values in the same group. So what will I do for this one? I will not paint it. So if I don't paint it, I will just what I will do is, like, I will just output 0. Yeah, they have told us that if you don't paint any index, you will output 0. So for that one's particular index in an array, in the initial array, I will input 0. Okay, so like that one, you could call it as my wastage, which I will not even paint. So if the number of occurrences, so the bottom line is, if the number of occurrences of any value in the initial array is greater than or equal to the number of groups, or the number of k, what I can say, k, greater than or equal to, then what I will do is, I will, without a shadow of a doubt, I will just paint the first k indexes, first k corresponding indexes of that occurrence of values as these colors one by one. And what about the rest of the values? Like if that value is far more greater, then I know that some values will be in between. If I even subtract those, I will just ignore those values, or I will just not gonna paint it. I will not paint it, meaning by I will just assume that they are 0. Correspondingly, their corresponding index would be 0. Now, what is the other condition? What if the occurrence of some number is less than, think about it, what if the occurrence of some number is less than k? Now, what does that mean? If it's less than k, think about it. If this 2, like, let's take example from the array itself. We had 2 1 times. We have 2 how many times? 1 times. We have 2 only 1 times. Now, what will we do is, yes, we have 2 only 1 times. Okay. What we're gonna do is, we won't add, if it's less than k, we won't add this initially in any of the groups. Understand what I'm trying to say. What I will initially only add in my corresponding groups when the occurrence of some numbers greater than or equal to k, then the first k indexes will correspond to the first k color groups. But if that is less than k, what I will do is, I will put them in a separate vector. How is this later gonna help us? It's later it's gonna help us. First, we are like considering this condition, and let's imagine that for that condition, when the occurrence is less than k, we are taking account all the numbers for that case, and we're taking, like, imagine we're taking that inside my vector. Now, after completing that task, with inside that vector, what we are left is bunch of numbers. They could be distinct or they could be non-distinct. Think about it. What was the vector for? The vector was for this condition, when the number of occurrence of some values less than k. Then we're going to take all the occurrences of that number inside my vector. How is this vector going to help us in the future in order to optimize the result? Well, after doing this task, or after gaining that vector, we will say that, okay, after completing all the possible operations and in taking that account of that vector, I will take that final vector's size, and if that size is then after that, what will I do is, from that size, I will try to find out whether I can make some number of groups where I can say that, okay, I will have x, y, z number of groups of k color groups. What I mean by is, okay, I will explain it with the example. Let's see. With the example, I will explain it. It will be easier. Now think about it. Here, 3 comes 2 times, which is less than what? K. and 2 is coming 1 times, which is also less than k. Think about it. For this example, 3 is coming only 2 times, 2 is coming only 1 times, which are respectively less than k or 3. So we've got 3 2 times, we've got 2 1 times, right? We've got 3 2 times and 2 1 times. What did I say? I will take them inside a separate vector after completing all the possible tasks. When I have my vector here, this is my vector. Now I will say that, can I make a possible k groups? Like, can I do something like that? Like, I already have, think about it, I already have my groups of k equal to 3. Now the final vector that I talked about for that condition, I will say whether this the size of that vector is greater than or equal to k. The final one, the final vector, is it greater than or equal to k? Yes, it is. If it was if it hadn't been greater than or equal to k, if it had been less than k, then we wouldn't be making or we wouldn't be like adding these numbers inside those groups, color groups. But as these values are greater than or equal to k, then I can be sure that yes, I could just easily put them in these respective color. Like, I could give it color 1, I could give it color 2, I could give it color 3, and so on and so forth. I hope you're getting what I'm trying to I'm trying to make you understand. This is the final vector, okay? This is the final vector for that condition that I've talked about, when the occurrence of some number is less than k. And I'm going to add those values inside my vector, and finally we're going to check that will be the final check, whether these values are helping me in order to optimize the result or not. Okay, but how am I gonna like understand that, or like how am I gonna know that it's gonna optimize it? I will simply check the size of that vector with k, compare it, and I will check whether that comparing, like whether that size is greater than or equal to k or not. If that is greater than or equal to k, then we're gonna simply go forward and try to add each and every corresponding color groups to that corresponding indexes. Similar cases are happening here. Now we have 3 3 2. Just we're gonna also track the pair as a pair vector, because we need to take care of the indexes too. So this 3 will also correspond to the original index of the initial array. Okay, let's show you the code section that you understand more. There you go. This is the code section here. So initially we're actually this is the part where I'm taking a 2D vector. Each and every value will contain how many indexes how many positions that value itself is in, and by taking account of that, we're gonna make sure that what is the occurrence of that number too. So occurrence of that number as well as the indexes, both are both works are doing at the same time inside this 2D vector. We could do that. Now after that, this is the first case that we were talking about. If that size of that vector of that particular number is greater than or equal to my total group of colors, then I will simply add the first k groups just like that. The res is the final resultant value that we're going to talk about, that we are going to output. Inside this VV of ij is referring to the initial index of the initial array, and we're assigning the color number just like that, first k, only the first k. We're not considering for the rest of them, because we're gonna just output 0 for those values. What if the other cases arises? If the other case arises, then we're definitely going to check whether that size is greater than or equal to 1, and we're going to simply add that vector. Remember that I've told you that I'm going to take those values for that other condition inside a separate vector. This is the vector. This is the vector temp. Now what is this doing? CNT equal to temp size divided by K. Simply we're just counting how many groups we can make of K. How many groups we can make of K groups of colors. Yeah, okay, so I think this line is unnecessary here. What I did was counting how many groups that I can make with this DD of 0, and P of 1 is actually corresponding to the groups, and these groups will follow up like cyclically. Like if K would be if K would have been 1, then it's gonna like move forward like that. 1, first one, then 2 and 3, and then 1 and then 2 and then 3. Okay, I hope you're getting that, what I'm trying to say. Basically it's just doing that and just printing those values and breaking out when my total count of groups of K colors is equal DD of the value that I'm actually comparing with, and finally outputting the answer just like that inside my result, and then also clearing out everything vector, or because there are some bunch of test cases here. So yeah, I hope I made you understand that. It was a great implementation problem. Yeah, till next time, goodbye.